Is it? Is it audible now? Okay. Okay, sorry. There was some technical issue. So, good evening, everyone. Welcome to the session. Today's rapid revision session is for liquid solution and colligative properties. So, I hope everyone is doing preparation with all their efforts, and everyone is fine. Everyone is good, right? So, let's start today's session. That is for liquid solutions and colligative properties. We are on the 5th lecture for our rapid revision session. So okay, and now let me tell you that how important this chapter is. Any day, let's say if there is, you can just see previous year's question. In every question paper, you will see that 2 to 3 questions are there for sure from this chapter. So it's a very important, and that too at the same time it's very easy chapter, because it has not a lot of things from where the question comes, but very pinpointed question comes. Chaliye aaye. What is that? Introduction to solution. A solution is nothing but it is the homogeneous mixture of any two components. Now, what we can say, homogeneous mixture of any two or more chemically non-reactive substances. Now, understand it. Non-reactive, why? It is not about why, basically. They should not be non-reactant, whose composition can be varied within certain limits. Basically, what we know that a solution contains two parts. A solution contains two parts. One is solute and another is solvent. Solvent is something, I hope everyone you know that it is in the larger amount, while solute is in the lesser amount, and the physical, whatever is the physical state of solution is there, that is same as the physical state of solvent. So solvent and solution has the same physical state. Because here we are going to study about liquid solution. So liquid solution means the solution is liquid. How the solution will be liquid? If the solvent we have used, that will also be liquid. Okay. So here today in today's session we are going to study about liquid solution. So a liquid solution will contain liquid solvent. So what the solute can be there? So we have to understand a solute can be anything. We are going to study about solute, that may be liquid, solid or gas, anything. So we are going to study about this today. Now components of the solution, everyone we know that there are solvent, solute, and binary solutions are those solutions in which there are two parts dissolved into it. Basically two components or two substances. Solution containing one solute and dissolving in given one solvent will be binary. When it will be, you can say trinary when there, let's say 3 components, quaternary 4 components. But here we are only going to talk about binary solutions. Next, concentration terms. What are the concentration terms? Now how much of amount of solute is present per amount of the, or you can say in the given amount of the solvent or solution, is known as concentration terms. How many types are there? There are 2 types. You can say type A and type B. Type A is something that is volume related, that is volume dependent. We can say that volume dependent, or volume related, that is temperature dependent. What we can say, because we know that volume and temperature has a relationship. If you increase the temperature, generally the volume also increases, while if you decrease the temperature, generally the volume decreases. So what we can say, wherever there will be volume term available in the given concentration terms, then that thing will be, or you can say that concentration term will be temperature dependent. How many are there? That percentage by volume. What we can say, percentage by volume, we can say that that volume of the solute by volume of solution multiplied by 100. Percentage by mass. What we can say, or you can say mass by volume also, it is the percentage mass by volume. So mass of the solution by volume of the solution multiplied by 100. Just for understanding, I'm writing S I will use for solute, sol I will use for solvent, and SOLN I will use for solution. Okay, just for sake of whatever I am going to tell, these things will be helping. Molarity. What is molarity? Molarity is nothing but the number of moles of the solute present per unit liter. You can say unit volume of the solution. So what we can say, number of moles of solute by volume of solution, and that too in liter. What if we are taking this volume of solution milliliter? We just do it multiplied by 1000 once the volume of solution is given in milliliter. And we can change the number of moles into anything, because we know that number of moles is equals to given mass by molar mass. Given mass of solute by molar mass of solute. So how can we say given mass of solute by given molar mass of solute into volume of solution in milliliter? Let's say it is given, that is generally given in milliliter only, and it will be equals to molarity. That's very important. Now let's go to the normality. What is normality? Normality is nothing but the number of gram equivalents of the solute present per unit volume or unit liter of the solution. What we can say, gram equivalents of solute divided by volume of solution in liter. Now, because normality in this whole topic, it is not going to be so important. That's why I'm not taking much out of it. Strength of the solution, that is in gram per liter. So what we can say, strength can be written as mass of solute in gram by volume of solution in liter. It will be what? It will be the strength of the solution. I think this is the basics. Everyone, you know that. That's why I can just say it directly. Now, group B, that is mass related, where there is not going to be volume but the mass. Per mass will be the main thing. So temperature, it is temperature independent, because generally we see that mass of any substance, if you increase or decrease the temperature, overall mass of whatever of the solution is there, whatever the solute or whatever the solvent part will be there, it will not be increasing or decreasing, right? Of course, the volume can be increased or decreased, but not the mass. Mass is whatever it is, it will be conserved. Next, by, so what is that? By mass. So it is mass of solute by mass of solution multiplied by 100. Mole fraction. Mole fraction is what? We can say that it is nothing. Consider there is two components, A and B are there. Consider there are two components. So what we can say, mole fraction of A equals to moles of A by moles of A plus moles of B. Or you can say moles of B equals to moles of B by moles of A plus moles of B. And always remember that sum of all the mole fraction is always equal to unity, or it is equal to 1. So sum of all the mole fraction of the different components inside a solution will be equal to 1 as a rule. Simple, right? Now, molality. What is molality? Molality is represented by small m. What is that? It is defined as the total number of the solute present per kilogram of the solvent, not solution. So what we can say, number of moles of solute by mass of solvent, that too in kilogram. So if I convert it into gram, what will happen? Number of moles divided by mass of solvent. See, I'm not writing solution, I'm writing SOL, that is solvent. If it, let's say that this is in gram, what you have to do? Multiply with 1000. And we can say that number of moles of solute equals to given mass by molar mass. Given mass of solute by molar mass of solute multiplied by mass of solvent in gram multiplied by 1000. I hope it is all very clear. Parts per million, how you can say? ppm can be presented by in many of the forms, but I will be writing in the term of mass only. So mass of the solute by mass of solution multiplied by 10 to the power 6. When the ppm is used, or when the ppb, the same, you can say its brother is ppb, parts per billion. It is equals to mass of solute by mass of solution multiplied by 10 to the power 9. When do we use these ppm or ppb? ppm or ppb are used for trace amount of solute. Let's say that there is very small amount of solute present inside the solution. So for such kind of solution, we use the ppm or ppb, that is parts per million and parts per billion. Understanding it? Let's say that, what are the examples? Like impurities in water, it is very small amount. Or let's say that there is in air, whatever is the atmospheric pollution is there. So that is there, that we do in the term of ppm and ppb. Now question is, an aqueous solution contains 30% weight by volume of urea. What weight of urea will be present in 5 ml of solution? Now understand it. Before that, I would like to give some of the interrelationships. Interrelationships between among concentration terms. Always remember whatever I am writing as it is. What is that? The first relation is mass by mass percentage equals to, or we can say that how do you write it in the terms of molarity? Let's say molarity in the term of molarity and mass by volume percentage. How do you say molarity equals to mass by volume percentage into 10 by molar mass of the solute. What is second? Molarity and mass by mass percent. How do you say this? For this, molarity equals to mass by mass percentage into density of solution in gram per milliliter multiplied by 10 divided by, or you can say multiplied. It will be written here, there only, divided by ms, that is molar mass of the solute. These are few relations. Next, third one, that is going to be that what we can say, molarity and molality. What is the relation? Molality equals to 1000 capital M by 1000 D minus M into MS. What are these things? Please remember always, what is this? Molality. Molality. It is what? It is both of them are molarity. It is what? Molar mass of solute. It is what? Density of solution. Density of solution in gram per liter. Please remember all these things, very important to keep in mind. What is this? Molality, it is molarity, it is density, it is molarity, and it is what? Molar mass of the solute. Now an aqueous solution contains 30% of mass by volume of urea. What weight of urea will be present in 5 milliliter of the solution? Now see that here mass by volume is given, percentage is given, okay, right? Mass by volume percentage is 30. What weight of urea? Now it is asking for what is the weight of the solute. Solute is what? Urea. And molar mass of solute is how much? I hope everyone can see that it is 60. Will be present in 5 ml of the solution. Can we see from here what we can say? We all, I hope we all know that 5 milliliter. So how do you say mass by volume percentage equals to mass of, I think that we do not need that. Mass of the solute by volume of the solution multiplied by 100. What is that mass of solute given? It is given 30%. And what is the mass of the, what weight it is asking? So Ws by volume of the solution is given how much? 5 milliliter. Multiplied by how much? 100. Cancel karo. How much? 20. So Ws will be 30 by 20. That is how much? 1.5 grams. So how much of the urea is needed? Very simple. 1.5 grams. 30 gram of urea dissolved in sufficient water to produce 200 milliliter of the solution. Calculate its molarity. What is the molarity formula? Molarity equals to, remember, given mass of the solute by molar mass of solute multiplied by volume of solution. It is given in milliliter or liter? Milliliter. Multiply with 1000. What we can say here? Given mass of the solute is how much? 30 grams. Yes or no? It is what? It is given mass of solute. What is the molar mass of urea? Molar mass of urea is 60. What is that? 60. Multiplied by volume of solution is how much? 200. Multiplied by 1000. Cancel karo. How many times? 5 times. Cancel karo. How many times? 12. How much it is? 30 by 12. Cancel it. 6 5s are and 6 2s are. That is how much? 2.5. So molarity will be how much? 2.5 molar. Okay. 30 gram of urea dissolved in 45 gram of water. Calculate the mole fraction of urea. What we can say? 30 gram of urea is there in 45 gram. So here mole fraction of urea. So mole fraction of urea will be equals to, from the formula, number of moles of urea divided by number of moles of urea plus number of moles of water. Okay, let's find out how much of the urea is there for 30 gram. So can we not find out this? Yes, we can, because we know that number of moles equal to given mass by molar mass. What we can say here? Given mass is 30. Molar mass is how much? 60. How much is this? 30 by 60 plus how much is the moles of water will be there? Given mass 45 by molar mass how much? 18. Can you do that? It is how much? Half. It is how much? Half. It is how much? 9 5s 9 2s. That is how much? 0.5 by 3. It is how much? 1 by 6. That is 0.166. So that is the mole fraction of urea. That is the mole fraction of urea in this solution. Next, 360 gram of glucose are added in sufficient water to produce 1.36 kilogram of solution. 1.36 kilogram को क्या बोल सकते हैं? We can say that it is 1000, or we can keep it as it is also. No issues. We can just directly, because it is given that 360 gram of glucose is there. Now molality equals to moles of solute by mass of the solvent. If it is given in kilogram, then you do not have to do anything. Moles of glucose, how do you say? Number of moles of solute will be equal to given mass, that is how much? 360, divided by how much is the molar mass of glucose? I think everyone you know that, 180. Cancel, how many moles are there? 2 moles. So NS is how much? 2. It is given mass. It is what? Given mass of solute. So from here, number of moles of solute is how much? 2. Mass of solvent is given how much? In kilogram. It is given 1.36. I hope you can do that. The rest of the solution, it's very easy. Just calculation part. Next. Which of the following is dependent on temperature? Temperature dependent are only those concentration terms where there is volume. क्या molarity में volume आता है? Yes, of course. Option A is the correct one. Dependent on temperature. Molarity only. Mole fraction? No. Weight percentage? No, because there is no volume. Molality? No, because there is no volume. Next, what is the mole fraction of the solute in 1 molar aqueous solution? Now, always remember, whenever there is such kind of question, mole fraction is asked while molality is given. Always go to the definition. What is the definition? What is the definition? Definition of 1 molar aqueous solution means, first of all, means it is telling that 1 mole of solute in 1 molar. What is the definition of molality? Moles of the solute present per kilogram of the solvent. Means solvent here is aqueous. Aqueous means solvent is what? Solvent here taken is water. Solvent here taken is water. So in 1 kilogram, that is also known as 1000 gram of water. 1000 gram of water. Of course, 1 molar means this much. This is only from the definition. What we can say, so number of moles of solute is how much? 1, while the mass of the solvent is how much? 1000 grams. So what we have got? We have got number of moles of solute. From the mass of solvent, can we not find out number of moles of solvent? We can. How can we? Because mass of solvent divided by molar mass of solvent, and solvent is water. Water has molar mass how much? Molar mass of water is how much? I hope everyone you know that it is 18. So 1000 by 18 is how much? 1000 by 18 comes out to be 55.55. चलिए आइए तो देखते हैं what is that. So in such case it is asking for mole fraction of solute. So mole fraction of solute will be equals to moles of solute by moles of solute plus moles of solvent. Moles of solute is how much? We have seen that it is 1 divided by 1 plus moles of solvent is how much? 55.55. So that is how much? 1 by 56.55. That will be somewhere coming out to be this 0.0177. Please check it. You will get that. Now let's go to the next topic that is very important. All these things were just basics. All these things were just basics. Now we are going towards the main points from the solution, that is solubility. What is solubility? Just break this word, solubility. Soluble and ability. So ability of any of the solute to be soluble inside any solvent. So solubility. So how much of any solute can be dissolved into a solvent? So how much means it is talking about the limit. So that maximum amount of any solute that can be dissolved in any given solvent, or that any amount of the solvent at any given temperature and pressure. So solubility of a substance is maximum amount of that can be dissolved in a specified amount of the solvent at that specified temperature. It depends upon the nature of solute and solvent. Always everyone you know that like dissolves like dissolves like. So if there is a polar solvent will dissolve only polar solute easily, right? And if there is a non-polar solvent, it will dissolve non-polar solvent. Or you can say if there is a hydrogen bonding possible, if both of them are capable of forming the hydrogen bonding, so in such case also the dissolution takes place. So that's why the rule is very simple, that is like dissolve like. So polar into polar, non-polar into non-polar, and if there is hydrogen bonding possible, so hydrogen due to hydrogen bonding. Temperature and pressure is also something that we you can say affects the solubility. So if you increase the temperature, always think if there is any solid, you are trying to dissolve it into some liquid. So if you are trying to dissolve it, just think about it. Let's say there is an ion AB. AB will be breaking into A plus and B minus. The more it will be dissociated, the more it will be dissolved, right? So the more the dissociation will be there, the more the dissolution will be there. Is that pakka clear? So in such case, always remember the forward direction reaction is dissociation, while backward direction reaction is what? It is, you can say that because it is associated, or we can say crystallization. Now, always remember dissociation is an endothermic process. It is an endothermic process. Endothermic process means delta H is more than 0 or delta H is positive. If something is endothermic, if you increase the temperature, the reaction goes in the forward direction. What we can say, if you increase the temperature, the reaction will go in the forward direction, and more the dissociation will take place. So more and more dissolution will take place. So always remember for solids, generally solubility, or we can say directly, solubility capital S increases with temperature generally. Next, let's say there is gas. So if you try to dissolve a gas, so for that gas, if you increase the temperature, gas will have more and more kinetic energy, so it will start leaving the water. So from inside the water, inside the solvent, they will start coming out of it. So dissolution of the gas will decrease. So always remember, on increasing temperature, solubility of gas decreases. Very important point. So solids generally increase, while gases not generally, always decrease. It is a rule. Always, these are the things that you should keep in mind. Now we are going to talk about the effect of pressure, that is Henry's law. Acha, effect of pressure on what? Effect of pressure on the solubility of the gas inside the liquid. Basically, we are going to talk about, and we are talking about the liquid solvents only, right? So now, what is the effect of external pressure on the solubility of gas on the liquid, or on the dissolution of the gas inside the liquid? चलिए ये देखते हैं. So the partial pressure of the gas in the vapor phase is proportional to the mole fraction of the gas in the solution and expressed as P equals to Kh into X. Basically, the more the pressure, the direct relation is what? Partial pressure is directly proportional to mole fraction of that gas inside the liquid. Means mole fraction of gas inside the solution. So the more the pressure will be there, the more the externally you will compress it, the more the gas will be dissolved into it. Now you can see that. Let's say that this is the solution we have, and there are the gas particles. When there was less pressure, when there was more volume, can you see there is more volume, means less pressure, P1 is less. So the gases will have more space to come out and just roam around here and there. But once we pressurize it, so what will happen? The pressure, after the pressurizing, the volume will be less, so the gases will have less amount of space to roam around. What will happen? They will go inside the liquid and they will get dissolved into it. What we can say? So when we increase the pressure, the gases will be more inside the liquid. If the gases inside the liquid be more, their mole fraction inside the liquid will also be more. So the rule is very simple. P is directly proportional to X of gas. Can we not say we have to use something that is, you can say, a proportionality constant, that is Kh. That will be P equals to Kh into X. What is that? Kh is Henry's law constant. Henry's law constant. Always keep these things in mind. यहाँ पर यही दिया हुआ है, as the partial pressure is increasing, can you see mole fraction of HCl solution inside the cyclohexane is increasing, right? So as the pressure is increasing, the solubility is also increasing. Can we see? Not a very tough thing, very easy. Characteristics of Henry's law constant, that is Kh. Very important, please note it down. यहाँ से question खूब आते हैं. Very many question, because theoretical thing is there. I hope it's very important, because पहली बात तो easy है. Second thing, question आते हैं. Unit same as those of pressure of torr or kilogram, because we know that P equals to kh into x. X is what? Unitless. It is what? Unitless. If it is unitless, so both of them will have the same unit. It has also pressure unit, so kh will also have the pressure unit. So either it will be torr, kilobar, bar, ATM, anything can be possible, right? Or ATM, anything. Now, different gases have different values of kh. That depends on the nature of the gas. So, on the different gases have the different natures, different amount of compressibility. Basically, the more the compressibility will be there, the more the dissolubility will be there. So, in such a case, it depends on nature of the gas. Next, the kh value of the gas is different in different solvents, and it increases with the increase in temperature. Always remember, kh is directly proportional to temperature. kh is directly proportional to T, that is Kelvin temperature. So, but we have already studied about it last time when we were studying, just a minute. We have already studied about it that on increasing temperature, solubility of the gas decreases. So, what we can say, if the on increasing temperature kh increases, but we know that on increasing temperature solubility decreases. So, what we can say? On increasing kh, the solubility will also decrease. So what we can say? Solubility is inversely proportional to kh. Always remember, higher the value of kh, the gas will lower will be the solubility. Yes or no? Next. Limitation of Henry's law. What are the limitations? Please keep in mind. When it works, when it does not. The pressure of the gas is not too high. When the pressure is not, the gas is not too high, right? The temperature is not too low. So temperature should not be very small. The gas should not go any chemical reaction with the solvent. If the gas starts the chemical reaction, then it will be a chemical reaction. They are dissolving into it due to the chemical phenomenon, not due to the any physical. Next, the gas should not undergo dissociation in solution, right? So these things basically from there only.